In this video, we're going to look at the market for reserves and talk about how one of these tools work that the Fed can use. In particular, what I want to look at for the tool is what are called open market operations. So to start with, let me sketch the market that we're going to use to look at these open market operations. So my market here will be this market for reserves. So what I have in mind here, as given in the posted notes, is some sort of a quantity of reserves on the horizontal axis. This is measured in dollars. And on the vertical axis, we put the interest rates. So as discussed in the notes, there's that demand curve and supply curve that are given. And so for my supply curve, we have a supply curve that looks something like this. Again, the way that works is there's a certain amount of reserves in the economy at a given point in time. That's what's called non-borrowed reserves. So many $1 million. These are the reserves that are held by commercial banks. So you can look at the reserves that Wells Fargo has. You can look at the reserves that Citibank has, and so on. You add all that up and you get this number. So it's some giant number measured in dollars. And then, as we talked about again in the notes also, at the discount rate ID, the supply curve levels off because commercial banks can go to the Fed itself and ask for loans at the discount rate ID and borrow as much as they want. So supply essentially becomes infinite. That's what I do for leveling off. And then we have a demand for reserves. This is demand by commercial banks for reserves that looks something like this. So here's my demand curve. As the interest rate goes down, commercial banks demand higher amounts of excess reserves. And this, we said, levels off here at the interest rate paid on reserves that commercial banks hold at the Fed. All right, so that's my model. This is what I use to answer almost all these questions in this chapter about tools of monetary policy. So what I want to look at today is looking at open market operations. So for open market operations, what the Fed can do is either purchase or sell securities. So we'll do both of these. So let's start with a purchase. So a purchase is just as it sounds. The Federal Reserve Bank, goes into the open financial markets and purchases Treasury securities. And what I want to do is see what would happen if they use this tool, open market operations, in my marketplace. So to start with, notice in my graph here, the supply and demand curve intersect at this specific point here in my graph. And that's always where my federal funds rate is, so my IFF. That's currently the equilibrium interest rate. If funds are trading hands in this market, they're trading hands at that rate where demand curve and supply curve intersect. So that's given here at my federal funds rate. So for a purchase, how does this work? What the Fed does is go into the financial markets, buy the securities from a commercial bank, and then compensate the commercial bank for the securities. So the idea here, right, is with this, you have the securities here. The securities go to the Fed, and then what the Fed does is compensate the commercial bank. And they compensate the Federal Commercial Bank with reserves. So what happens is, when the Fed buys those securities, they take the securities out of the economy and push reserves in. And the reserves go to the commercial banks that they bought the securities from. What that means is now, after that transaction, the amount of non-borrowed reserves goes up. So we jump from this amount to this amount. So there's higher non-borrowed reserves in the economy. So what I do is, after that purchase, regraph supply. So my new supply curve is going to look essentially like this. Or what I have here is it levels off at the same place, but I've moved that vertical segment of supply to the right. And this old one disappears. Consequently, you can find the new equilibrium rate. So the new equilibrium rate would just be where the supply curve now intersects the demand curve. So I go from here to here, and if I go across over here, this would be my new federal funds rate, like IFF2. All right, so as a result, if I'm looking at a market for reserves like this, after the purchase, we would say that IFF, my federal funds rate, falls. And this is one tool that the Fed has available to itself. That is by trying to, if they say want to, as a target, lower the interest rate, the equilibrium interest rate. Given how the market looks, how we set it up, one option is to purchase those securities, and then the interest rate goes down here. So let's look at number two, as I was saying earlier. Let's look at a sale now this time. So we have in mind again is suppose you start with a situation that looks like this. So I have my demand curve and my supply curve. So my discount rate ID is here. Let's say that I have a federal funds rate there, and this is my quantity. Okay, so what you can see is in this graph, currently IFF is less than ID. So sometimes in the homework problems that'll be given. It says suppose that IFF is less than ID. All right, that just means I have my demand curve intersect the supply curve somewhere below the discount rate. And so what we wanted to look at is in a market that starts like this, what happens if the Fed sells securities? So they have huge amounts of these treasury securities on their balance sheets. They can go into the financial markets and sell these to commercial banks. All right, so in this case, the securities go from the Fed to the commercial banks. The commercial banks have to buy these securities from the Fed, of course, so the commercial banks pay the Fed in reserves. In this case, what's happening is the securities are going into the economy and reserves are going out of the economy. The reserves, again, go from the commercial banks to the Fed. So if we start here with a non-borrowed reserve amount here on the horizontal axis, the amount of non-borrowed reserves is now going to drop because those reserves leave the economy and go from the commercial bank to the Fed. So what I'm going to do is just shift this vertical part of the supply curve to the left. And then this part of the supply curve disappears. Okay, so the Fed sells securities. What I have here is my vertical part of supply shifts left, we said. And we get a new equilibrium rate. What's the new equilibrium rate? Well, this was my initial federal funds rate. So that's my market clearing rate. And now you can see, given this new supply curve that I've sketched in, the demand curve and supply curve now intersect at this point here, which is a higher rate. So my federal funds rate's going to climb. I go from down here to up here now where these two curves intersect. All right, so I have a new equilibrium rate. That means my federal funds rate rises. So if I start in a situation like this, then what I see is that the federal funds rate goes up due to the Fed selling securities. Okay, so last part to this video is just to illustrate that things can sometimes look different if we start off in a different scenario. Like this time, what happens if we assume that the federal funds rate is equal to the discount rate? In the previous two graphs, what we had is a supply curve that looks like this and a demand curve that intersects supply curve down here. This time what I'm going to do though is put this demand curve off to the right more. So it actually intersects supply here at this this horizontal part of the supply curve. What that means is my discount rate is here, just as in the previous two graphs. And you can see that the federal funds rate, what has happened is it's gone all the way up this vertical segment and is actually equal to the discount rate. So for example, if the supply curve had been back here, right, then the federal funds rate would cross this. The federal funds rate would be right where demand and supply cross. But if I shift this out to the right, eventually this thing's going to go up, the federal funds rate, till it equals the discount rate. All right, so what I'm going to do is say, in the market for reserves, assume that currently IFF equals ID. What that means is that the graph should look like this, as opposed to a demand curve down here. So we start here. So look what happens next. So say, for example, we do what we did a minute ago. So say let the Fed sell securities. So as we said, if the Fed sells securities, this is an open market operation, the securities leave the Fed and go to the commercial banks. The commercial banks pay the Fed, so the commercial banks pay the Fed with reserves. So that means reserves leave the economy. That is, the amount of reserves is going to go down. So if I have non-borrowed reserves here, then the non-borrowed reserves are going to move or shift over to this, just like we did before. So I have something like this as my new supply curve. Again, all I did is shift the vertical part of supply to the left. And this is my new non-borrowed reserves amount, NBR2 call it. All right, so they sell securities. What I did is do vertical part of supply, shifts left, we said. After it shifts left, we might ask, what happens to my equilibrium rate in this case? Equilibrium rate is always where the demand curve intersects the supply curve. What you can see here is, this is a little tricky, is if this was my initial equilibrium rate, if this part of the supply curve disappears and shifts over to the left, so this is my new supply curve, right? If I highlight that, make that bold, this is my demand curve. Where do these graph now? Where do they intersect? Well, when I shifted this over to the left, you can see it had no implications or no effect on exactly where they cross. They still cross at the same point. The demand curve hits the supply curve here, which means on the vertical axis, IFF is still equal to ID. So when I shift this vertical part of supply to the left here, I'm having no effect on the market rate. So for my equilibrium rate, the correct answer would be, in this case, it doesn't change. So no change to the equilibrium rate as a result of this open market operation.